My name is MARCY OSHIN DUHISIN and my matrix number is BB21110171. For part 1, these are the data provided in the question. To find the data, we must first convert the data into a graph like this. After getting the data, use the relative frequency formula and cumulative relative frequency formula to find the relative frequency and cumulative frequency data. After that, sort the data into the domestic airlines tables and international airlines before creating the graph. The data provided on the relative frequency graph for domestic airlines begins at 0.458, which is the highest, to 0.042, which when added together equals to 1. Meanwhile, the cumulative relative frequency range from 0.458 to 1 according to the table and graph. The difference in each bar in the relative frequency graph is because it indicates the ratio of the number of times a value of data happens in the dataset. However, the OGF shows growing data because cumulative frequencies represents the sum of the relative frequencies. Meanwhile, the data supplied on the relative frequency graph for international airlines start at 0.857 to 0.042 according to the table and graph, which when combined together equals to 1. Meanwhile, the cumulative relative frequency range from 0.875 to 1 after being added with the last relative frequency data. The difference between both graphs is due to the relative frequency data depicts the ratio of the number of times a value of data occurs in the data set, whereas the OGF shows expanding data because cumulative frequency represents the sum of the relative frequency. Overall, the difference between both types of frequencies happen because relative frequency is for the ratio of the frequency of a particular event in a statistical experiment to the total frequency, while cumulative relative frequency is the sum of the relative frequency.
My name is AMYLLINE EBBY BB2110700. Next, we move to part 2, calculate and compare measures of central location in each data set. A single number that represents the data set center serves as a measure of central location. There are 3 common measures of central location, which is mean, median, and mode. Mean is equal to the sum of the terms divided by the number of terms. In this question, mean is equal to sum of the domestic or international airlines passenger divided by number of airlines for domestic or international. So the mean for domestic is 1,113,828.958, while mean for international is 456,067.417. We can find the median by using the formula given. In this question, we need to sort the data in an ascending order before calculating the median. So the median for domestic is 570,799.5 passengers, while 808,666 passengers for the international. Hence, there is no mode for domestic and international airlines because there is no frequently occurring value in a data set.
My name is REZKI Binti BB211100315. I will present part 3. First of all, each data should be arranged in an ascending order as we can see by this table. This is a summary value tables for domestic and international airlines. From the data that we arrange, we can find minimum and maximum value for both. We can calculate the percentile using the formula given, which is LP equals to n plus 1p per 100. The answer for 25th percentile is 240,976.75 passengers, while for 50 percentile is 570,799.5 passengers, and the 75th percentile is 1,628,064.5 passengers. To find the outliers, we need to calculate the IQR using the formula which is Q3 minus Q1. So IQR equals to 1,387,087.75. Then we use the IQR to calculate the lower limit and upper limit that we will use in our range data. This is the box plot for domestic airlines. Any value that's smaller or larger than the range are considered outliers. So the outliers is 4,570,798. We use the same formula which is LP equals to n plus 1p per 100 to find the 25th, 50th, and 75th percentile for international airlines. To find the outliers, we need to find the IQR and then we use the IQR to calculate the lower limit and upper limit that we will use in our range data. This is the box plot for international airlines. Any value that's smaller or larger than the range are considered outliers. So for international airlines, the outliers is 320,474, 1,273,829, 2,974,856, and 4,713,336. So here we can conclude that there are many outliers in the international airlines compared to domestic airlines. The more outliers in data set, it can impact the mean of data, and the standard deviation also increases when the outliers is included.
Hello, my name is RUSSEL ABDON, my metric number BBV21110166. So next I will explain question for part 4. First, the range, the formula is maximum value minus minimum value. So for domestic we get 4481969 and the international 4680974. So we can conclude that the international airline has a higher value for the range than the domestic airline. Next, for the mean absolute deviation, for domestic we get 909,795.365, international 632,818.229. We can conclude the international has smaller value for mean absolute deviation than the domestic, meaning the international has less diverse dataset. For variance and standard deviation, for domestic we get 1189431.587, international 1102383.768. So we can conclude international airlines have a smaller standard deviation than domestic. Next, for the coefficient of variation, domestic we get 1.0679, international 2.4172. Since international is greater than domestic, we can conclude that the data for the international has more relative expansion than the domestic.
JULIET OLIVERRA Church BB2111051 I will present about part 5 calculate and compare measure of association in each dataset. The covariance describes the direction of the linear relationship between two variables domestic and international. The correlation coefficient describes both of the direction and the strength of the relationship between two variables domestic and international. The table shows about the differences between each data value and the sample mean for the domestic and the international variable. Sum of the sample domestic international is 2421675051325.406. Here for the formula sample covariance, and the sample is 1053551089188.061. For the sample standard deviation we can get from part 4. Here the formula for the sample correlation coefficient, and the sample is 0.803495267112. The value of the correlation coefficient is 0.8035. This is a strong positive correlation, which means the high domestic variable score go with the high international variable score for the passenger traffic of all airlines in the Asia Pacific region.